Welcome to the video demonstration of Big Cloud Fabric support for multiple logical virtual pods. Big Cloud Fabric's orchestration integration allows multiple isolated vCenter clusters and/or multiple OpenStack clusters hosted on Big Cloud Fabric in parallel as virtual pods. The multi-virtual pod deployment enables overlapping IPs and overlapping VLAN usage across virtual pods. This also enables the repurposing of compute node from one vPod to another by just adding that respective node to the new virtual pod cluster. Big Cloud Fabric's host auto discovery and Fabric config automation will take care of adding that node logically to the new virtual pod. In today's demo, I'm going to show Big Cloud Fabric hosting 3 virtual pods on the same physical Big Cloud Fabric. The Big Cloud Fabric used for the demo has 3 rack topology with set of compute nodes across all 3 racks. First virtual pod hosts Red Hat OpenStack Platform 7 based BCF P Fabric with Neutron ML2 integration. Second virtual pod hosts vCenter based BCF P Fabric with BCF vCenter integration. And third virtual pod is built based on the Mirantis OpenStack with Big Cloud Fabric P+V integration. In this virtual pod, BCF controller manages both physical and virtual networking for the OpenStack with BCF integration with Neutron, ML2 and Layer 3 plugin. In all of the 3 virtual pods, orchestration integration is done centrally on the Big Cloud Fabric controllers. Goal for today's demo is to show how these virtual pods coexist on same Big Cloud Fabric. The benefits of BCF integration with vCenter or OpenStack P only or P+V integration will not be covered in detail in this demo, as those integration benefits have been covered in detail in prior videos available on bigswitch.com. First, let's look at the Big Cloud Fabric physical topology and host auto discovery for all the compute nodes in all the virtual pods. This is the Big Cloud Fabric controller web interface. This is the Fabric page, which gives the graphical representation of physical topology. This demo topology has 3 racks. The compute nodes are connected across these rack leaf switches. Bottom of the screen shows the virtual switches, which is part of the BCF P+V pod, where BCF controller manages both physical and virtual switches. Let's look at the host auto discovery and the auto link aggregation by going to the BCF port group page. This page shows all the link aggregation on the Big Cloud Fabric, both static and auto configured. The mode column in the table indicates the mode of the lag, static or auto created. The name column indicates the name of the lag, which is actually name of the compute node in case of auto configured lag. For today's demo, we have 3 virtual pods and all compute nodes are auto discovered and form link aggregation to the compute nodes using the LLDP. The first set of compute node belong to virtual pod 1, which is Red Hat OpenStack Platform 7 based virtual pod. Second set of compute node link aggregation belong to VMware vCenter virtual pod. Third set of compute node link aggregation belong to the BCF P+V OpenStack virtual pod. As you can see in the mode column, it is connected to BCF virtual switch and auto detected. If you click on any of the port groups, it will show the switch and the interface details for that server link aggregation. If you want to add or move compute nodes to the virtual pod, you can add or move the nodes at orchestration layer. BCF controller would auto detect the node and form the link aggregation and also does the auto network configuration based on the application topology through the integration with respective orchestration platform. Now let's look at each of the virtual pod. First, Red Hat OpenStack pod with Big Cloud Fabric P-only fabric with OpenStack Neutron ML2 integration. This is Red Hat OpenStack orchestration platform. Let's log in as admin. As you see, we have 3 projects or tenants, including admin tenant. Other 2 tenants are Apple and Orange. Now let's look at the Apple tenant and its application network topology. This has 2-tier topology with 2 networks, web tier and app tier, and tenant router to interconnect both the networks. Let's look at the BCF controller tenant page to see all the tenants and networks configured. As you can see, there are few tenants configured. From the origination ID field, you can identify that the following three tenants belong to virtual pod 1, which is orchestrated by Red Hat OpenStack 7. If you click on tenant Apple, it shows the configured segment, web, and app for Apple tenant. The tenant topology view provides graphical representation of the application network topology, similar to what you saw on the OpenStack dashboard for the given tenant. This configuration on BCF is done automatically through the Neutron ML2 integration, which essentially provides the self-service model to the tenant application deployment. Let's look at the second virtual pod. This is orchestrated by VMware vCenter. The BCF integration with VMware vCenter provides the fabric config automation and visibility into physical and virtual networking. This is the vCenter web interface. I have following network topology with multiple vCenter port groups. These vCenter port groups and associated VLANs are configured and enabled on the BCF as you enable the vCenter integration on BCF. BCF integration tab allows you to configure vCenter integration. In this demo, I have one vCenter vPod. You can add multiple vCenter virtual pods by adding individual vCenter details by clicking on the plus sign on top. Once you enable the integration, it provides a dedicated tenant for the vCenter workloads. So it is isolated from other virtual pods you have on the big cloud fabric. If you click on the tenant, provides all the segment config which maps to the vCenter port groups with associated VLAN. Again, all these are dynamically provisioned on the BCF as you create and delete the port groups on the vCenter. And this provides logical topology for the vCenter virtual pod. And this is a vCenter page on BCF, which provides single pane for monitoring both physical and virtual networking for the vCenter virtual pod. The third virtual pod is again orchestrated by OpenStack. In this virtual pod, Big Cloud Fabric is used as P plus V fabric. That means BCF manages both physical and virtual switch for the OpenStack and provides the full integration with the Neutron, both ML2 and Layer 3 plugin. Let's log into Mirantis OpenStack Horizon dashboard. We have three projects or tenants on this virtual pod as well. Blue and red tenant along with admin tenant. Let's look at the blue tenant network topology. Blue tenant has three-tier topology: web, app, and DB tier. Blue tenant in this vPod uses the same overlapping IP as the Apple tenant in virtual pod 1, that is 10.100.41.0/24, 42.0/24. Let's go back to the BCF tenant page. Last three tenants on this page associated with this virtual pod identified by the origination ID. Click on the tenant blue, you would see the segments got created for blue tenant, web, app, and database segment. This is the graphical representation of network topology for blue tenant. In this pod, Big Cloud Fabric does both Layer 2 and Layer 3 networking for OpenStack and provides the distributed virtual routing for all the OpenStack workloads. This you can make out from the logical router and gateway IP configured for each of the segments. In summary, as you saw in the demonstration, Big Cloud Fabric's integration with multiple orchestration allows multiple isolated virtual pods to be hosted on same physical Big Cloud Fabric, which is orchestrated by multiple vCenter and or multiple OpenStack platform in parallel, by keeping all programmability and automation centralized at the Big Cloud Fabric controller. Thank you for watching.